Hello, this is Unit 4, Module 3, Session 4. The name of this home connection is Running the Race. Please place your name and number at the top, please. Let's dig in. An open number line is how they want us to solve these problems. So I am going to start by drawing what I hope is a relatively straight line for us to work with. And it needs to be open, so I put arrows on either end. Ta-da! It says Anna started a race at 9:30. She ran for 3 hours and 47 minutes. What time did she finish her race? Well, she started the race at 9:30. So I think we should put a mark on our number line labeled 9:30. I am going to put AM. And then we need to get 3 hours and 47 minutes in the future. So if I just wanted to go ahead and do 3 hours right away, so if I went 1, 2, 3 hours. So this is 9:30. This would be 10:30, 11:30, 12:30. And notice I'm going to switch to PM now because I went past noon, right? And if you want, you could label a +1 on all of these jumps just so that you know you've got your 3 hours done. Okay? 47 minutes, it's not a great number to work with, but I am at 12:30. What if I took 30 minutes out of here so that we could get to a nice friendly number? So I'm going to do a plus, and I'm going to do colon 30 to suggest that means 30 minutes, okay? And we would get to 1 o'clock p.m. Okay? Now, the only subtraction that we're going to have to do at this point is to figure out what 47 minus 30 is. If it's too much to do in your head, then stack it and subtract it. 47 minus 30. Okay, put in your subtraction sign. What are we going to do here? 7 minus 0 is 7. 4 minus 3 is 1. And I'm just going to throw this out there. You got a test coming up real soon. I would get used to just doing the math by hand. Have some scratch paper available so that you know you are good to go. Now, according to this, I took 30 minutes out of here, so I have 17 minutes left. So if I go from 1 p.m. and I go plus 17 minutes in the future, what time should I be at? 1:17 p.m. Okay, that's what time she finished. It also wants us to use an open number line for question 2 as well. So I am going to start by placing a number line on our question. Michael and Tyler both ran a half marathon. Michael finished in 1 hour and 42 minutes and 13 seconds. Tyler finished in 97 minutes and 49 seconds. Ooh, so now we have this, there's an hour hidden in here, isn't there? Because we know that 1 hour is 60 minutes, right? So we've got an hour and some change buried in there, okay? So we want to know who was faster, okay? And then how much faster was he? Now, if we just did, let's say, we just have a starting point. Okay, and we would say this is 0, 0 time. 0 hours, 0 minutes, 0 seconds. And we do Michael first. So we're going to go 1 hour and 42 minutes. So I'm going to go 1 hour, and then I'm going to go 42 minutes. Okay, so this would be plus 1 hour plus 42 minutes. And then I'm going to go plus 13 seconds. Okay? I'm going to switch colors on my pen, and then we're going to see what we can do here with Tyler. Tyler went 97 minutes, so we know Tyler, I'm going to do this on the bottom side, he can go 1 hour, because that's 60 minutes. Here again, we're going to have to do the subtraction where we do 97 minus 60. Some of that could be done in your head, but if not, here it is. 97 minus 0 is 7. Or excuse me, 7 minus 0 is 7. 9 minus 6 is 3. So now I have 37 minutes that I'm going to jump over. So this one, the blue, Michael, he went 42 minutes. He only went 37 minutes, so I'm going to hop just not quite as much. Okay, 37 minutes. Okay, and then 49 seconds. That's going to be hard to label. Plus 49s. Oh, that's so tiny. Now, we want to know who was faster. This might look a little confusing, but this number line is telling us how long they ran. So it took Michael this long to finish. It did not take as much time for Tyler. So who was faster? Well, I hope you're going to write Tyler. It says, how much faster was he? This is where it's going to be maybe a little bit more challenging, but still doable. 42 minutes versus 37 minutes. We can forget, and maybe I'll do this in pen, we can forget this hour, because they both, black pen, there we go, because they both went the same hour, right? Here's our issue, 42 minutes versus 37 minutes. So what am I going to be doing? I'm going to be taking 42 minus 37 to figure out our minutes difference. 42, 37. Ah, finally, some more on the floor. So we finally get to borrow. So if I borrow a 1, which changes that into a 3, then I have 12 minus 7. That's 5. 3 minus 3 is 0. So this is a 5-minute difference. Okay? But then I have this 13 versus 49. That's going to be a little tricky. I can't really take 13 seconds and subtract 49. Doesn't really work that way unless I borrow one of these minutes. Okay? What does that look like? We know that if we take 1 minute out of this time, I end up with 60 seconds. So if I could convert this to 4 minutes plus 60 seconds. That's still 5 minutes, because 60 seconds is 1 minute. So I can break 5 minutes down into 4 minutes in 60 seconds. That's going to help quite a bit. So I'm going to add 60 seconds to this 13. What happens if I add 60 plus 13? I'm going to get 73. Now I can subtract 49. And I really want you to follow along here because we cannot forget this number when we get our answer, okay? I'm only taking this 60 seconds and adding it up here to have a friendlier number to work with. There's more on the floor. I go next door. So I have a 13. This changes into a 6. Okay? 13 minus 9 is 4. 6 minus 4 is 2. So that's 24 seconds. So once again, I cannot forget this 4, which used to be 5, right? I borrowed 1 from it. But when you borrow a minute, you're borrowing 60 seconds, right? So I have 24 seconds and 4 minutes, which means my answer is going to be he was faster by 4 minutes and 24 seconds. That is a tough one. So many steps there. But if you pause and think, you can get there. It just takes maybe just a little bit of brain power. And you could technically go to a number line and be a little bit more specific. Maybe almost thinking of it as zooming in on those minutes and seconds. But it is nice at some point to just do some stacking and subtracting, borrow from the minutes if there's too many seconds remaining. Okay? That might be a problem to try on your own once you think you have it down. Takumi ran the first mile of his race in 450 seconds. How many minutes was his first mile? Ooh, so I have to convert this into miles, into minutes. Well, there's a couple ways we can do that. You could do a ratio table, right, where you did minutes versus seconds. 1 minute is 60 seconds. 2 is 120. 3, 150. 4, what is that? 180. Wait, hold on. 240, excuse me. 240. 5 would be 300. Let's see, 6 would be 4, let's see, 360. 7 is 420. And then 8 minutes. If I could get my, I guess I could have zoomed in, didn't realize how far away that was. And then if I could sneak in an 8, which I'll just put down here. I'll just 8. Okay, it's 480. So, 7 is 420 seconds. 8 minutes is 480 seconds. How did I get that number? By taking this number times 6 and adding a 0. So you could forget all these zeros here if you wanted to. But 1 times 6 is 6. 6 times 2 is 12. Oh, that should be 180. Haha, thank you. 6, 12, 18, 24, 30, 36, 42, 48. You just, because we're working with 60 seconds in a minute, you just have to add the zeros on. 450 seconds doesn't quite fit. In this ratio table, I have 420. I have 480. 480 is too many. I can't say that he ran for 8 minutes, but I could say he ran for 7 minutes, and I just have to figure out what's left. So he ran for 7 minutes. Ooh, wow. Having trouble spelling today. But how much is left? Between 420 and 450. If that mental math is a little too much, we could stack and subtract. 450 minus 420. 0 minus 0. 5 minus 2. 4 minus 4. We've got a 30-second difference. So this would be 7 minutes and 30 seconds. So ratio table works pretty well if you're converting seconds to minutes. However, if this was a very, very large number that you couldn't do very quickly in a ratio table, you might consider just using the times 6, add a 0. What do I mean by that? Let's say that the number was 720, okay? And this is just an example. 720 seconds. You would have to think to yourself, 6 times what is 72? Isn't it 6 times 12? If you weren't sure, you could do a quick multiplication. 6 times 2 is 12, carry the 1. 6 times 1 is 1, plus 1 is 7. So you know that 12 would give you, 12 times 6 would give you a 72, which means that 12 minutes, 720 seconds equals 12 minutes. Okay, so it might be easier to think of a times 6, add a 0, because then you can get these two numbers to match. Okay, that's just me thinking out loud. Johanna used tiles to build a rectangular array with an area of 54. List all the possible dimensions of the array. So, in other words, a rectangular array. Okay, so one of these is longer than the other. Okay, let me make this look longer. Okay, and we have to figure out how many ways can you get an area of 54, which is take the width times the height to get an area of 72. Oh, excuse me, 54. Read the question wrong. What dimensions will give me a 54? Well, we know that 1 times 54 is 54. Always start with that factor pair. That's a guaranteed. We also know that this number is even So I can take 2 times some number to get 54. How am I going to figure that out? That's kind of a tough one. Well, I do know that 2 times 25 is 50. So maybe it's 2 times 27. Should we figure that out? There you go. It is 27. Okay. I also know that because 5 plus 4 is 9, and 9 is divisible by 3, that there's also going to be a 3 in there somewhere. What do we think? I know that 3 times 15 is 45. I know 3 times 20 is 60, so that's too big. So it's going to be somewhere between 15 and 20. So maybe I'll try like an 18. So if I do an 18 times 3, that's a 24. Carry the 2. 3 times 1 is 3 plus 2 is 5. Oh, there's a 54 as well. So a 3 times 18 equals 54. Is there anything else? I'm wondering if any of our... Oh, I see one. Something times 9 is 54. That's just a math fact that I just had in my brain. What is it? If you count by 9s, 9, 18, 27, 36, 45, 54. How many was that? 1, 2, 3, 4, 5, 6. 6 times 9 is also 54. So that is a tough, tough problem. And if you want to, dig in some more, see if you can find another one. 54 seems to be a fun number to get, have factor pairs. Okay? And that's all of the possible dimensions. So this could be 1 tall 54 wide, 2 tall 27 wide, 3 tall 18 wide, 6 tall 9 wide. You're going to get 54 no matter what. Ooh, rounding, rounding. What is 3,000? Excuse me. What is 329,456 rounded to the nearest 10? So I'm going to be looking here. So I have to figure out, does 56 round up to 60 or down to 50? Well, we know since 6 is higher than 5 that it is going to round up. 329,460. Now, if I'm thinking rounding to the nearest 100, I'm trying to see if 456 rounds up to 500 or down to 400. So I know it's going to be 329,000, but is it going to be down to 400 or up to 500? Well, I need to look at this 5. 5 is a 5 or above, so that has to round up to 500. And this last one you're going to do on your own, but let me set it up. I'm looking at 9,456. That's what I'm focusing on, okay? Because it says round to the nearest 1,000. So we know the 32, the 32 is going to stay the same. But I have to say, is this going to round up to 10,000, which would make this a 33? Or is it going to round down to 9,000, which would make, which would eliminate these numbers? You're going to be looking at this digit right there. Pause and figure that out. Fill in the bubble to show which number below is closer to 445,890. So my options, I guess I can zoom out so we can see it. I have 450,000 or 440,000, which looks like they're rounding to the nearest 10,000, which means we need to look at the digit before to figure it out. So regardless of what you're rounding to, you're always going to look to the previous digit to figure it out. What do I mean by that? If we were trying to round to the nearest 100,000, I look at the 10,000 digit. If we're rounding to the nearest 10,000 digit, I'm going to look at the thousands. If I'm going to round this to the nearest 1,000, I'm going to look at the hundreds, so on and so forth. So you have to look at this 5 and determine whether it's going to round up or down. If you wanted to round 373,417 to the nearest 10,000. Which number below would you choose? So we're rounding to the nearest 10,000, which means we need to look at the thousands place to determine whether we round up or down. What is the rule? 4 or below, you round down. 5 or above, you round up. Okay? Look at that 3 and determine what you would do. Linda plans to sign up for 3 field day events. She wants to run a total of more than a kilometer, but less than 1.5 kilometers. Which 3 events should she sign up? Her choices are these. Okay? So, just a quick review. A kilometer, so 1 kilometer equals 1,000 meters. It's good to know. That'll be on your test, 100%. And we've been working with it for a few days, so it might as well sink in. We wrote it in our handbook. It's in great places, right? So, but we're trying to add up to 1.5 kilometers. So if 1 kilometer is 1,000 meters, how much is 5/10 or 1/2 of a kilometer? Well, what's 1/2 of 1,000? 500. So I could say, so I'm trying to get a total between 1,000 and 1,500. That's my goal, because she wants to run more than a kilometer, so it can't be 1,000, it has to be more than 1,000, but it has to be less than 1,500. Okay, so we can only choose how many events? 3. So if you wanted to, you could say, well, that's out, because that by itself is way too much. Let's look at this. 800. Are there a few enough to get this to work? Let's see, 800. I was trying to disprove this. 8, 9, 10, 11, 12, 1,300. Ooh, there might be a couple ways to do this. Well, there's a couple ways we can't, right? I couldn't do these 3, because that doesn't even get me to 1,000. Maybe the bigger numbers. 4 plus 3, 7, 8, 9. So there's no way to get 3 events without using the 800. So we know we need the 800-meter run for sure. Okay, I have to get to over 1,000. Okay, so if I did this one and this one, what would I get? So that's 800, 9 to 1,100, 1,300. Oh, well, man, it looks like there's a couple ways we could do this. 800 plus 300. Well, let's write that down. 800 plus 300 equals 1,100. Okay, we just can't get to 1,500. We have to avoid that. So we just need one more event. So we could say even the 100-meter dash. Let's see. So 1,100 plus 100 equals 1,200. Great. We're still in the ballpark. That is more than 1,000, but less than 1,500. So there's a few different ways to solve that. So she can choose any of those. Now, if any of these were maybe a little bit too much for you to come up with on your own, or you found yourself thinking, wow, he explained it, but I just am not sure how he got that answer, you should talk to a math wizard. Your teachers in particular love to help you. Find him, ask him, just to make sure that you don't have any gaps in your understanding of these skills and concepts. All right? Check you later.